mg sin theta plus fk we can write. But fk is equal to fk. But fk is equal to, sorry, mu k. Mu k is equal to fk divided by r. Therefore, fk is equal to what? Mu k into r we can write. But r is equal to mg cos theta. Therefore, this is equal to mu k into mg cos theta we can write. In place of fk we can write mu k cos theta. It is only for inclined plane. Otherwise, simply mu k into mg, no cos theta. If it is a plane surface, that we have seen already in the last part. Therefore, this is equal to mg sin theta plus mu k into mg cos theta we can write. What are the constants? Mg is taken outside. That is equal to sin theta plus mu k cos theta. Mu k cos theta we can write. So this is the force. Now, but then is equal to force into displacement. Then that is equal to mg into sin theta plus mu k cos theta, the whole into, yes. But then by the force can be calculated. How much work is done for a body being pulled along an inclined plane with a uniform velocity upwards. The total work then is equal to mg into sin theta plus mu k cos theta into f. Right? This is one thing. So a very important thing. Suppose the body is moving downwards with suppose the body is moving downwards like this. Okay. When the body moves downwards, suppose the body is moving downwards with a uniform velocity. Sorry. Body is simply moving downwards, then if is in the opposite direction. That is next thing. Body is moving down, so all these things you will note down. Right? So we have discussed the body moves in the upward direction, then inclined plane 1990, theta with the horizontal. That is done. Next is, suppose the body is moving in the downward direction. In this case, motion is along this direction. Motion like this. Okay. Then the total force acting on the body are what? Mg or fk minus mg sin theta also you can write no problem. If the force is equal to, that means the body is moving the uniform velocity. In that condition, we can write fk minus mg sin theta also we can write. The total force. Fk is equal to what? Mu k into r. R is equal to what? Mg cos theta. Mg cos theta. In that condition, you can calculate the work done in this case also, right? The downward force is mg sin theta, or fk is the frictional force. Or we can write mg sin theta, the body is moving downwards with mg sin theta. Therefore, this force is more than this force. More than this force means you will be getting confused. If the body comes down with a uniform velocity, then you will be confused. So better say fk is acting upwards, mg sin theta is acting downwards, right? For the body to move with the uniform velocity, the force acting can be given as F is equal to fk minus mg sin theta. That is F is equal to what? Fk minus mg sin theta we can write. Fk is equal to mu k into what? Mg cos theta minus mg sin theta we can write. Here mg sin theta is taken outside. Mg sin theta is taken outside. You will get mu k cos theta minus sin theta we will write. Mu k cos theta minus sin mg into mu k cos theta minus sin theta. Therefore, W is equal to Fs. That is equal to mg into mu k cos theta minus sin theta, the whole into yes. But then can be calculated. When the body is coming down what? The frictional force is acting in the opposite direction. Right? The body is coming down with the force is equal to Fk minus So now Fk minus mg sin theta for the body to move with the uniform velocity. This is the function. Right? Yeah. So that is also done. Next thing is, what is that? Up to now we were talking about the work done by a constant force we are talking about. Now we are going to talk about the work done by a variable force. Suppose variable force is acting on it. What are variable forces? Variable forces means gravitational force is a variable force. Spring force is a variable force, right? Electrostatic force is a variable force, right? So these are variable forces. Suppose that two bodies are kept at these 2 points. This body is M1, this point is M2. Distance is equal to D1. Suppose the same particles are kept at long distance. This is M1 and this is M2. The distance is D2. Now, D2 is greater than D1. So two bodies are kept on the same place, but when the distance is less, the force is more. The distance is gradually increasing. The force is going on decreasing. So we can say that the gravitational force acting to two bodies is not a constant force, but it is variable. That distance, that depends on distance. When distance increases, the force goes on increasing. Distance decreases, the force goes on increasing. Force goes on increasing. So such force is a variable force. For example, a spring is a spring. Spring force is also a variable force. Suppose the spring is compressed or elongated. At different values of compression and elongation, the force acting on the hands that used to press it or elongate it is going on changing with the displacement, changing with the extension or changing with the compression. So spring force, the force applied to the spring at different values of compression. As it is compressed or it is extended for different values of compression and extension, the force applied by the spring is always changing. So spring force is a variable force. The force acting between two charged particles kept at a distance between is also variable force. At different distances, the electrostatic force is also different. And the same thing, the magnetostatic force is also a variable force. So there are so many examples of variable force in nature. So when a variable force is acting on a body, the work done, how we can calculate? To calculate the work done by a variable force, what we have to do is, as a variable force is going on